All right, moving on here with chapter 8, we're going to look at this thing called the dot product. Okay? What the dot product is, it's basically vector multiplication. That's important because it tells us how vectors interact with each other, okay, which is what we're going to look at. So I give you two vectors here. Here's a simple vector v with an a1, b1, vector w, a2, b2. All you do for the dot product is multiply the corresponding parts and add them together. So the a's get multiplied, the b's get multiplied, and you add them. Okay, dot product will always give you a number. So there's no i's, there's no j's, it's just a number. Okay, it can be positive, it can be negative, but that tells us how two vectors interact with each other. So we're going to do a lot of these here throughout this section. So I give you two vectors. Okay, obviously we could draw them, we could find the magnitudes, we could add them, subtract them. Now we want to look at multiplication with them. Okay, so again, you can see the four basic operations. We're doing them with different types of things kind of all year. So we want to multiply these guys. I'm going to pause it here and just show you guys kind of the work in the answers just to save some time for some later stuff. I'd encourage you to put these in your notebook and see if you get the same things I do. So multiplying two vectors is really as easy as taking the two i components, multiplying them together, taking the two j components, multiplying them together, and adding them. This first one comes out as a -3. You can multiply two of the same vectors together, and that guy comes out as 29. So like I said, we'll use this process a lot this lesson, so just kind of a little intro thing there. Here's some properties of them. Okay? Now these just kind of make sense. So if we have three different vectors, u, v, and w, here's what can happen. It shouldn't matter which order you multiply them, because if we go back to what we just did, it wouldn't matter if I did w times v, I'd get the exact same numbers. I'd just get 5 plus minus 8 instead of the other way around. Okay, so it doesn't matter what order you multiply two vectors, just like it doesn't matter what order you multiply 4 times 7. Distributive property also works as well. So I could take u and add it to w and then multiply it by v. So remember, we add vectors simply by adding the i's, adding the j's. Or I could distribute this v as well. So I could dot v and u, and I could add it to dotting v and w. Okay? If you take the dot product with 0, you should get a 0. That just kind of makes sense there, because there's 0 i's and 0 j's. And if you take the dot product of the same vector with itself, it's basically just the magnitude squared. So that one should be really easy to prove. So we should be able to take the magnitude of v here, and this would come out as the square root of 29. Now if we square that, we get what happened right there. So that proves if you dot two of the same vectors together, it's just the magnitude squared. So it'll get rid of that square root for you. Now, if we have two vectors and we want to work on finding the angle in between them. So yesterday we didn't look at this. Okay? We just kind of did some intro stuff. So u and v are two vectors, and the angle theta is in between 0 and pi. Well, if you think about it, if I got some vector here and I want another vector in between it, okay, really the furthest away from it can be is back this way, which is exactly 180 degrees. Okay? It could be the exact same vector with an angle of 0 degrees. It could be, you know, a little vector here with a smaller angle in there. The furthest it can be away is 180. Here's the formula. To find the angle in between it, we're going to say cosine of theta is the dot product of the two vectors divided by their two magnitudes multiplied together. The proof's actually really cool because it uses something you guys know. If we take this simple picture here, so here's a vector v, here's a vector u, obviously there's some angle in between them. This is u minus v. Okay. So that would be this little guy in here that we're looking at. So it's going to be u minus v would take it exactly back this way from beginning to end, would be that guy, which is the same as this one right here. Proof comes from law of cosines. I give you this picture here, you would say this squared equals this squared plus this squared minus this times cosine of alpha. You do a law of cosines based off that picture right there, this is what will happen. So you'll have all these formulas available to you, you just need to know what they're used for. Okay? So it is kind of a cool application of stuff we've used before. So find the angle between these two guys. All we do is find the dot product on the top. Okay, magnitude of u, I'll find that guy over here just to keep everything nice and neat. Magnitude of v is going to be square root of 16 plus 9, so that's square root of 25, so that just comes out as 5. And those are multiplied on the bottom down here. So this is 5, square root of 5. All we got to do is clean this up. Now, clearly your angle in between something is not 1 divided by square root of 5. Okay, we would want a degrees here. So all we did is this right side here. So what we have now is cosine of alpha is 1 over the square root of 5. No need to rationalize this because we're just going to use our calculator anyway to find this angle. Make sure you're in degrees because that's going to make more sense to us. We are going to inverse cosine 1 over square root of 5. Okay, 63 degrees. So that would be your answer. So I asked for the angle theta in between those two vectors. It's got to fall between 0 and 180 because it's the furthest they can be apart. That's what you basically found. So if we actually plotted these, 4i plus 3j takes us to here. 2i minus j takes us down to here. Okay, so we can see it's going to be something smaller than 90, obviously. We do all that work, we inverse it like we said. That's what I want you to tell me. The angle between those guys is 63 degrees. Now, how do we know if vectors are parallel or perpendicular? Well, two vectors can be parallel if there's a non-zero scalar, so basically something that's just bigger than it, or just, some whole number, so that v equals a times w. So basically, if you were able to say, okay, all vector v is 6 times vector w, okay, then they would be parallel. All right? Now, that means if you were to do this and you use that formula we have with the cosine of theta, you have to get that to come out to be a good number for us. So if two vectors are going to be parallel, the angle in between them is 0 or pi. So if I put a vector here, if it's parallel to it, it can be exactly on top of it, or it can be over here. So you're trying to figure out what's the cosine of 0 degrees, and what's the cosine of 180 degrees, okay? Luckily, those are the exact same thing. So you can get a 1 here. Cosine of 180 is exactly -1. So if you can get the angle in between two vectors to be 0 or 180 degrees, then they are parallel. In part 2, we'll pick up right with parallel perpendicular vectors.